Hello, in this video we will learn how to factor polynomials of degree 3, but only a very special case. Factoring polynomials of degree 3 is extremely hard, but we'll see just a specific case, and which is just as hard as what anybody can give you, basically. Anything harder is just impossible to do with the knowledge of algebra 2. So, the special case I'm talking about is having x cubed minus b, some b. So, in this case, x a0 of the function is when x is equal to cube root of b. So this is very basic. However, it's very important to know that when factoring this out. So if we already know that cube root of b is a 0, we know that x minus cube root of b is one of the factors of x cubed minus b. If we know that this is one of the factors, we can actually just do long division and find the other two factors of, or now just a polynomial of degree 2, which can have two factors or can only have one factor. We don't know. We will have to do it for every specific case. But so we will reduce this to a polynomial of degree 2, which we know how to get the factors of. And the rest of the procedure is trivial. However, you might wonder, how do we know that this is true? That if we have this equation that one of the factors must be x minus cube root of b. Well, this is true because if you have x cubed minus b, you know that to find its 0, you can just add b to both sides. You get x cubed is equal to b, and then get the cube root of both sides, and you're left with x is equal to cube root of b. And this is one of the zeros, right? And as you may recall, the definition of a factor is that when a factor is equal to 0, then the whole polynomial is also equal to 0. But now we're kind of taking the inverse of this. So when the whole polynomial is 0, there must be at least one factor that is equal to 0. So knowing that when the whole polynomial is equal to 0, there must be at least one factor that is equal to 0. We know that if a 0 of the above equation is cube root of b, then a factor must have a 0 where a cube root of b as well. And of course we know that x minus cube root of b will for sure be 0 at cube root of b. So knowing that, let's do an example. Let's say that we had x cubed plus 27, and we want to factor this out. Well, as you may recall, here we had a negative. This means that if you wanted to find the 0 of this, you get x cubed plus 27 is equal to 0, and when we subtract 27 from both sides, you get x cubed is equal to negative 27. And when you get the cube root, you get that x is equal to negative 3, because the cube root of negative 27 is negative 3. So this is exactly the same thing we had before, which is that we have the negative cube root of b, And so you can think of this just as x cubed minus negative 27. And just treat negative 27 as the b and work from there. So now, and you know that x minus negative 3 must be a 0, and so must be a factor, I'm sorry, so that's just x plus 3. So if x plus 3 is a factor, then we can just do long division. So remember that we must add the 0 terms for whatever is not there, divide x plus 3. So if we do this, you should already know how to do it, but let's just review. You want to multiply something times x to get x cubed, and so that must be x squared. So if we distribute, we get x cubed plus 3x squared. We subtract this, so we get 0 minus 3x squared, and we bring down the next term, which is just 0x. So now what do we need to multiply x by to get negative 3x squared? Well, that's negative 3x. And if we distribute, we get negative 3x squared minus 9x, and we subtract this, and you get 9x, and we bring down the 27, or plus 27. What do we multiply x by to get 9x plus 27, and that's well, x to get 9x, and that's just 9. If we multiply that times 9, you actually get just 9x plus 27, and so this just equals to 0. We subtract them and we get 0, and so this is the result of our long division. So we know that the factor of x cubed plus 27 is x plus 3 and x squared minus 3x plus 9. And you can also factor out this this factor of x cubed plus 27, but it's a little bit complicated since there's not an easy a and b that would make it 0. But yes, that's the big picture, the big idea, and that's how you can factor out a cube, but it's just a special case, a polynomial of degree 3. So you will actually use this video to solve an example about partial fraction expansion in the next video. So that's why this tutorial is here in this chapter.